Okay, so I'll just go through all the basic stuff that you need in this differentiation. The first one is the product rule where two functions are multiplied together. This becomes extremely important in year 12 where this is two functions multiplied together. It's a function of x here, which is x, and a function of x here, which is sine x. So you can have loads of different things like this, like x squared times cos x, or x squared times e to the power of x, or exponentials and logarithms. So it becomes very, very tricky at times, and it involves lots of different things. So the derivative of a product, uv, is vu dash plus uv dash. Now, I like to think of it in the bottom part here, the derivative of ultraviolet equals violet ultra plus ultraviolet. So the letters just like reverse, so to speak, and the derivative is always on the back one. So it's like the derivative of ultraviolet is violet ultra, the derivative of ultra, plus ultraviolet with the derivative of violet. The other way you can look at it is it's the derivative of the function multiplied by a function is the second times the derivative of the first plus the first times the derivative of the second. So if we look at a few examples, here's an example. Here's the formula up here that you might see. So what have we got? It's a product because it's this function of x multiplied by this function of x. So it's going to be this times the derivative of this, which is 6, plus the first times the derivative of the second, which is 4x squared. So when we do that, there it is. It's the second times the derivative of the first, plus the first times the derivative of the second, and the derivative of the second is 4x. Once you get to this line, it's probably fairly simple from there. You just expand the brackets. Not much can go wrong. You expand the brackets and you simplify. Let's look at another one now. These are basic questions. These are really band 2, band 3 questions that you should all be getting these right towards the end of year 12. It's another product rule. So it's going to be the second times the derivative of the first. Ultraviolet is violet, the derivative of ultra. So it is the second times the derivative of this. And what's the derivative of that? -1 plus the derivative of the first times the derivative of the second. So what you get is there's the second times the derivative of the first there, -1, plus the first times the derivative of the second, which is 2x. And then again, once we get to this line, the rest is just simplifying. So -1 times this gives us -x squared -2. 2x times 5 gives us 10x minus 2x squared, and then we're simplifying, collecting like terms. If we've got the quotient rule, it's obvious that it's a quotient rule because it involves a divided, but it's pretty much the same formula up top here. It's the derivative of ultra divided by violet is violet ultra, derivative at the back, minus ultraviolet, derivative at the back. So again, it's ultraviolet, violet ultra, ultraviolet. That's one of my students came up with that. In words, the derivative is you write the second or the bottom term times the derivative of the top minus the top times the derivative of the bottom, and it's all over v squared. Now, the one thing you have to be careful of is this minus in here, because when we do some examples, you'll see that. Here's the formula. So what are we doing here? We're writing down the bottom times the derivative of the top. So it's going to be 4x minus 1 times 3 minus the top times the derivative of the bottom, and then it's all over v squared. So when we do this, again, 4x minus 1 times 3 minus 3x plus 2, what's the derivative of this? 4. And it's all over the bottom squared, the 4x minus 1 all squared. Now, this is the tricky part. The first part's easy. 3 times 4x is 12x. 3 times 1 is 3, so it's minus 3. Now what we've got is this minus changes everything. So 4 times 3x is 12x, but it's minus 12x. 4 times 2 is 8, but it is minus 8. And again, once we get to there, it's just collecting like terms. And this last one, it's a little bit more happening here and a lot more negative. So again, what are we going to do? It's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom. So when we look at that, it's the bottom, 2x minus 3, times the derivative of this, which is 4x, minus the top times the derivative of the bottom, which is just 2. And of course, it's all over 2x minus 3 all squared. Now, if we look at this, again, the first one here is 2x times 4x gives us the minus 8x squared. Minus 3 times minus 4 gives us plus 12x. And I've put these in brackets because we're going to minus when we expand this. 3 times 2 is 6. 2 times this is minus 4x squared. But this minus changes both of them. So what do you have? You have minus 8x minus 4x squared, which is going to be just minus 4x squared, plus 12x minus 6. So again, once you get to this, it's a bit tricky here with this minus on the top. So you've just got to be careful there. And show your working. If you show your working, you'll probably get it right. The chain rule, which is the last one, these, again, it's obvious, it involves brackets. Sometimes they trick you with square roots. They become very, very powerful, but we're just going to do some basic ones to start with. And what is it? You just bring down the power and minus 1 from the power like you would normally do, but then you've got a times by the derivative of the bracket. So in words, the power is brought down and you decrease the power by 1, but then you multiply by the derivative of the function or by the bracket. So if you look at this, again, it's a really nice simple one. We're just going to, the derivative is going to be 5 outside of 3x squared minus 4 to the power of 4, but then you times it by 6x. So here it is. I've brought the 5 down, minus 1 from the 5 to give 4. So that's just nice, simple differentiation. The only difference is we've got to multiply it by what's in the bracket. So what's the derivative of this? 6x. So that just gets 30x outside of 3x squared minus 4, all to the power of 4. You cannot take that in because this is to the power of 4. Let's look at another example, nice, easy. So what are we going to do? We're going to bring this 7 down. It's going to be to the power of 6, but then we've got to multiply by everything in this bracket. So when we do that, we bring the 7 down, 2x squared minus 3x to the power of 6, but then you've got to multiply it by what's inside this bracket. What's the derivative of this? 4x minus 3. So there it is there, 4x minus 3. And then again, you're just collecting like terms or multiplying this bracket out, really. That's the proper term for it. We're expanding this bracket. 7 times 4x is 28x. 7 times 3 is 21. Now, can we expand these brackets? Can we multiply out? No, because this is to the power of 6. Okay, if it wasn't, that'd be okay, but this is to the power of 6, and we have to do this first. Okay, so hopefully that's just gone through the basics. Hopefully most of you can understand that, and then we'll get into some harder ones. Thanks.